Welcome, this is your favorite celebrity lecturer. Today we'll be looking at glycolysis. What is glycolysis? Breakdown of glucose, that is the lysis. So here we look at the conversion of breakdown of glucose to pyruvate via subsequent release of ATP, which is the form of what? Energy. But we are going to go through the series of steps that are required to produce the pyruvate from glucose. So the first step is the conversion of glucose to glucose phosphate. So that reaction is catalyzed by hexokinase. Hexokinase, from the word kinase, whenever you hear the word kinase, it means that there is phosphorylation, but the phosphate group is coming from ATP or GTP, but any of the high energy phosphate compounds. So yeah, you can see that ATP is utilized to produce ADP, while the phosphate group is attached to the carbon 6 of the glucose. So this is now what we call glucose 6 phosphate. So the glucose 6 phosphate, now mind you, magnesium is required for this step. That is why we have a deficiency in magnesium. You might likely have low energy, or the process of which our body produces energy will be very minimal. So magnesium is required for energy production. So you can see that the glucose has been converted to pyruvate. Now you also notice that this is a irreversible step. Irreversible step. That means glucose cannot be converted back to glucose 6 phosphate cannot be converted back to glucose. So we say the step is irreversible. In order to reverse the step, we have to circumvent. But in circumventing, that's why we look at gluconeogenesis. So watch out for my next video on gluconeogenesis. But let's continue on glycolysis. So now the glucose 6 phosphate that is formed, remember the phosphate group is at the 6th position of the glucose molecule. This is carbon 1, 2, 3, 4, 5, carbon 6. So the phosphate group is at the 6th position of the 6th carbon atom of glucose. So the next step is conversion of glucose 6 phosphate to what? To fructose 6 phosphate. In fructose 6 phosphate, what we call the isomerization reaction. So glucose 6 phosphate is converted to fructose. This is just ring opening and ring rearrangement to form from a peran ring, which is the glucose ring, to a furan ring, which is the fructose ring. So you can see here the phosphate group is still at the 6th position of the fructose moiety. So the name of the enzyme that converts this glucose 6 phosphate to fructose 6 phosphate is phosphoglucoisomerase. So this is an isomerization reaction. That means both glucose and fructose are isomers. That means they have the same number of carbon, number of hydrogen, number of oxygen. So the next enzyme, this is the reaction 1. This is reaction 2. So the next one is conversion of the fructose 6 phosphate to fructose 1,6 bisphosphate. So in this reaction step, it is catalyzed by PFK1. PFK1, which is phosphofructokinase 1. The one indicates that the phosphorylation is at carbon 1 of the fructose moiety. So we have fructose 1,6 bisphosphate. Remember, this reaction step, which is the third reaction, is irreversible. It's irreversible. This is the third step. It is what? Irreversible. So in order to bypass this step, we need to circumvent using a different enzyme. But that will actually come into play when we're explaining gluconeogenesis. So now the fructose 1,6 bisphosphate that is formed will be cleaved. Will be cleaved by an enzyme. This is the fructose 1,6 bisphosphate here. So it will be cleaved by the enzyme aldolase to form 2 molecules of 3 carbons each. The first molecule is dihydroacetone phosphate, which is the HAP, and glyceraldehyde 3-phosphate. So the conversion of that is actually the 4th step of glycolysis, which is the cleavage of fructose 1,6 bisphosphate to form dihydroacetone phosphate and glyceraldehyde 3-phosphate. Now, okay, let's take a moment and subscribe to the channel. Click on the subscription button and also the notification bell for more updates. The dihydroacetone phosphate is not an intermediate for glycolysis, so there is need to convert the dihydroacetone phosphate to glyceraldehyde 3-phosphate, which is a major intermediate for glycolysis, which is actually the substrate for the second phase of glycolysis. So that means the conversion of the HAP to glycerol 3-phosphate is actually the fifth step, and that enzyme is catalyzed by triose phosphate isomerase. Triose is actually 3-carbon sugar, phosphate isomerase. That means it is an isomerization reaction. So this enzyme belongs to the class of enzyme called isomerases. So the next step, which is the payoff phase. Remember, the first step is where we invested ATP at position 1 and at position 3. So, but the next phase is actually called the payoff, where we actually harvest the energy that have been invested in the first phase of glycolysis. So here, this is the first oxidative state of glycolysis, whereby that is catalyzed by glycerol 3-phosphate dehydrogenase. So say G3PDH, glycerol 3-phosphate dehydrogenase. This enzyme requires inorganic phosphate that comes into the process, that comes into the reaction process, and also NAD plus that is used as an oxidant for this reaction part step. So this NAD plus is converted to NADH plus hydrogen. So that means 2 molecules of hydrogen have been removed from glyceraldehyde 3-phosphate to form a 1,3-bisphosphoglycerate. So the name of the enzyme that convert that is glycerol 3-phosphate dehydrogenase. So this enzyme oxidize this molecule to form glycerol 1,3-bisphosphoglycerate. So here you find out that once that have been converted to G3P, it means that we have 2 G3P. So the first G3P will go into the reaction to produce ATP. The second one will also go into the reaction to produce ATP. So now in this case we have 2 glyceraldehyde 3-phosphate. So whatever we are discussing henceforth, it means that we are considering 2 molecules of glyceraldehyde 3-phosphate. So that is okay. We now have the 1,3-bisphosphoglycerate that is formed, 2 1,3-bisphosphoglycerate that is formed will not be acted upon by bisphosphoglycerate kinase. This enzyme is where the first ATP is synthesized, which we call substrate level phosphorylation. That means the phosphate group is coming from a molecule, a substrate. So it's called substrate level phosphorylation. So ADP comes in to produce 2 molecules of ATP. Mind you, what we also have there is 2 molecules of ADP coming in to produce 2 molecules of ATP. So the next stage is conversion of we now have the 3-phosphoglycerate, which is converted to 2-phosphoglycerate by the enzyme called phosphoglycerate mutase. So the enzyme converts 3-phosphate, which means just taking the phosphate group at position 3 to position 2. We have the 2-phosphoglycerate. Mind you, this is a reversible reaction. The next one is a conversion of 2-phosphoglycerate to PEP, which is catalyzed by enolase. Enolase will remove water molecule to introduce a double bond between the carbon 1 and carbon, between carbon 1 and carbon, no, this is carbon 1, 2, 3, between carbon 3 and carbon 2. So that's enol, this is an enol functional group, which is a double bond. So from the phosphoenol pyruvate, it is converted to pyruvate using the enzyme pyruvate kinase. So pyruvate kinase will phosphorylate ADP to form ATP. So here we find out that we have 2 ADP coming in and 2 ATP produced. So at the end of the day, this is where the ATP is being produced. This is another way ATP is being produced. How many ATP do we have in total? We have maximum of 4 ATP produced from glycolysis. So how many was used for investment? 2. How many was produced? 4. So minus 2 plus 4, we have a net 2 ATP produced from glycolysis. So if you ask how many ATP is produced from glycolysis, say a net 2 molecules of ATP is produced from glycolysis. Do not forget to subscribe to our channel and click on the notification button for more updates on biochemistry videos.